Tweet. It's a chain of system context. Everything is a chain of system context. Okay, let's do it. So where are we at? We're writing some Python, of course. Where are we? Let's just go ahead and put it in its own. Should we do this? Yeah, let's just go ahead and pull this out into its own file right now. Because we have way too much going on, let's be honest. So let's pull this into its own file. Okay. So we'll say system context. Maybe we'll just call it context. No, it's system context. All right, so we make a directory, we create the file. All right, so there it is. Let's go vim it again. So where was this code that we were just looking at? Okay, where is this? What file is that? This is in diff. Wow, we're all over the map here. Okay, start. Okay, let's just do this. We have more system context code over an overlay. Let's put it in system context. Okay. System context config. So we're pulling the system context out of the scratch code that we basically just threw an overlay. And we're playing with the API. We're playing with the API. Right? We're just getting a feel for the ergonomics. So what are we looking at? So links, fantastico. Let's see. System context.load dict. Okay. So what are we going to want for that? Well, we're going to want to go into, I swear this exists. Where is it? Where's entry point? Oops. Is this entry point? Yes, it is. Load mutable, load dict. There it is. Oh. Uh-oh. Well, what if we don't? You serious? Loaded dot entry point label. I guess it sets entry point label. It's just really, really not ideal, but it works for now. Um, we'll just do this, right? And then we'll say, to-do, to-do. Sure. It's probably cleaner if we do that, right? So we should probably do it. Okay. Okay. So the name, maybe we'll just leave that as the to-do there. There. Okay, so right, because then we won't grab the name from that. So that's kind of like the only comment we really need there because it's pretty obvious what's going on there, right? We're just like, all right, well, ideally we would do it this way. So no, okay, let me just say that. That's not obvious enough. Okay, so ideally we would have load not setting properties on the loaded classes. And then we'll put the to do there so that it's more obvious because or else that might get lost. Okay, so YouTube is working. Okay. Links, upstream, overlay, orchestrator. So we also discussed in the thread time. Let's see, so class time. So what is time? Well, time is the past, which is also time, the present, which is also time, and the future, which is also time. So looks awfully similar, looks just like this to me. So I think that we're going to be able to turn the system context. I think if we took a system context, right, with, so we have a system context as links. Perhaps the upstream, no, the links. Links live within overlay. Don't get it wrong. Okay. I keep screwing that up. So the links live within the overlay. So, okay. So how do we turn the system context into time? And then how do we time travel? Okay, so past, the present, and the future. Upstream, the overlay, the orchestrator. Okay, so the upstream and the overlay. The upstream and the overlay. So I believe if we apply the overlay to the upstream, we should have a complete description of the present and the future and the past. Future. The future, though. So the past and the present, we know by combining the upstream and the overlay. We also know the future because we can make predictions using our system context. So where does the orchestrator come in here? So the upstream and the overlay. The upstream, the overlay, and the orchestrator. Well, let's just try to let's just write some pseudocode for time traveling here. So let's see what happens. Okay, so the past, present, and the future. Okay, let's just say point A and point B. How do we get it from point A to point B? How do we get from point A to point B with the system context? The system context. The past, the present, and the future of point A and point B. So the past, the present, and the future, point A and point B. How do we get from point A to point B in time? Well, we know we can only travel forwards in time, and that time is relative, and that the states of consciousness which we see entities in as described by the strategic plan outputs, aka this conceptual layers, which we may be viewing in this case as states of consciousness if they were overlapping clustering models with things we would consider to be states of consciousness. It's also just sort of like a general, like, I think what did I say? I think this, what was it? So I have like way too many notebooks now. So consciousness, is it in this one? Okay, consciousness. Okay, okay. So, so, okay, so the conscious and the subconscious. Okay, so the conscious and the subconscious. The conscious and the subconscious. So the subconscious, okay, so still playing with this, right? But so the subconscious, let's go to the notes. So subconscious, uh, okay, actions or subconscious, operations, okay. Subconscious, something's happening, there's control without analysis because we have the control analysis, or control feedback data, wait, data, we have this loop where we're ingesting input data, right? And so um, for a conscious state to exist, consciousness, consciousness means that something is being done with that data more than a predefined action, right? So subconscious, anything that's subconscious has been predetermined at the tick, right? So we're going tick tock, right? So as we go from the present to the future on each tick, maybe we should define the tick. Tick, present. Oh, no, this is important. Present and the future. When we go from tick tock, there's only the present and the future. This is our muscle memory. Tick. Okay. So the present and the future. The present and the future. So we can, the argument is, not argument. Okay, wait a minute. Okay. Time. Get rid of one of those. Time. Past, present, future. System context. System context is the upstream, the overlay, the orchestrator. Time is the past, present, and the future. The tick. The tick. The tick. With the tick. Okay. Okay. So tick. On tick, we have the present, the system context. We execute it. On talk, we enter the future. We're constantly going from tick tock, as we switch from what is effectively one system context to the next, if we look at all system contexts as if they were unique, right? So for that state of consciousness, Okay, so, oh yeah, there was something in here. So time is relative. Time is relative. Time is relative because time is relative because, and why does time fly when you're having fun, right? Because your brain desires input data and it rewards input data, right? Because it wants to learn. Your brain's function is to learn. So, tick-tock. Okay. So, between the tick and the tock, the function is to learn. Between the tick and the tock. Fuck. Okay. Come on. The upstream, the overlay, the orchestrator. The past, the present, the future. The present and the future. What are we doing? What are we doing? We're in many states of consciousness in parallel. We also have many active subconscious states. Within the system context, should we analyze the system context for subconscious and conscious states, we would see conscious states are identified by control, like by input to analysis to control, whereas subconscious states are directly to control of some kind. So, directly to control, directly to control. Things we know are going to happen. Subconscious states, and conscious states. Now, and they're not necessarily different things. It just depends, once again, on the context within which you are executing, right? Because what is subconscious? What is a subcon? Okay, so think about them as almost subflows. So slice the graphs based on what. So visualize the system context as graphs, right? Now we overlay, right? So visualize a flow which is now going to, read the data of all the so we're doing an overlay, right? So we're going to grab a bunch of output data from all those operations, right? And we're doing a strategic plan overlay here, right? Because we're doing a conceptual level, which will be a state of consciousness or subconsciousness. And we're going to grab all those outputs from the upstream. We're going to consume them in the overlay and make a determination as to what patterns within the upstream fall within the conscious states and the subconscious states for a given entity, where a given entity is defined as something with state. Entities have state, fundamentally. So what about Alice? What if Alice is ephemeral? Well, Alice is only ephemeral because her state is distributed. And so it's called on demand. And this is why, okay, so, and it's not particularly that's in it. So an entity, anything can be viewed as an entity in this representation. And anything could potentially have a state of consciousness or subconsciousness. Because we're looking effectively, we're just looking at the data and we're seeing patterns and we're identifying what patterns map to analysis before feedback or before control and what patterns map directly to control, right? So conscious versus subconscious. So what was the thing? What was the thing? Okay, so the point of this was um, oh, and I forgot to write this part. So if, so snapshot, right? Remember, so Alice is, so once again on the ephemeral nature of Alice, right? So Alice is she's, all of a sudden, boom, the world comes alive, right? And Alice is there, poof, she exists, right? Now her job, now she discovers what her job is, what context within which she is operating, right? And then she goes about executing that function. So the conscious states. So because oh yes. Okay, so optimal communication. So there's a hypothesis. So optimal communication exists when entities uh, are in entities, or no. Don't even worry about entities right now. Don't even worry about entities right now, because entities are sort of a sub. You could have an entity attached, what we would consider an entity attached to some states of consciousness, like that they're specific to that entity. But because these states of consciousness are more of like, yeah, they're patterns that we're seeing. There, now I've got two pens. They're what? Okay, so but time. Okay, so the states of consciousness. So the hypothesis is that optimal learning occurs when communicating agents are in aligned states of so optimal communication, which is effectively optimal learning, occurs when agents are in aligned states of consciousness, right? So effectively, when you have aligned system context, right? So what is an aligned system context? Well, an aligned system context is when you have shared states of consciousness. This is the hypothesis, right? So here, one way that we can determine alignment is via analysis of states of consciousness. And So, what, like, this is basically saying, okay, so is this environment conducive to communication, right? Is this environment conducive to giving me the data that I need to optimally learn, right? Because what is the goal of communication? Well, the goal of communication is, uh, uh, I mean, you're communicating for some purpose, right? So if you already knew, you wouldn't have to communicate, right? So you're learning what it is that needs to be done, right? And then doing it is also a form of communication as well, because the other party uh, may, would view that, right? So if two people are working together, right, they're both moving a bunch of boxes, they don't have to talk to each other to know that they're because the communication becomes visual, right? So remember, I think I misspoke um, about context and language. Um, and the fact that it's not that we can have communication without language. It's that communication is really uh, more about having you can have more than one language involved, and that all of that is those languages exist within the context, and those languages are patterns. Languages are patterns. Languages are patterns understood by both agents. Languages are patterns understood by both agents, and therefore shared states of consciousness are like the lens through which the agents viewed the world. And if they're viewing the world in the same lens, the language becomes more effective because because the state of consciousness is also a language in a way, because it provides this shared frame of reference, or no, what is it? Okay, there's something good there. Okay, so the states of consciousness. Um, okay, so the language is a pattern. Shared states of consciousness is like having a shared language. So the more languages you have that you can use to communicate, the more shared states of consciousness a shared state of consciousness is like anything. So okay. So basically, what we're going to do is we're going to say, uh, a language like, okay. So right now, what we're thinking of, we're talking about our communication, right? And our hypothesis is that we can transform, any system state from one state to the other, provided we have adequate or optimal learning, aka optimal communication, right? Um, so basically, like if we work together, we can do anything, right? So that's that's the point. So and so can the computer, right? So can Alice. So and she can work with us. So so patterns, languages. So the shared states of consciousness effectively. Well, not okay. Okay. So okay, so the subconscious and the conscious, the subconscious and the conscious and the shared states of consciousness. So we can almost look at this as the shared states of consciousness. So if we see one entity, so one chain of system context, one entity is, but both entities are their chain of system context puts them in a classification, some kind of unsupervised classifier bucket, right? We're going to call that we can call that a language. We can call that okay, so we're observing a pattern in the Okay, forget the entity. We're observing a pattern in system context. We observe a pattern in system context. What is an entity? It's an entity matter here. Okay. Fuck. Okay. TikTok. Fuck. Okay. Yeah, I'm pretty sure the consciousness and language effectively. Never mind. I don't want to. I'm not pretty sure. I'm not pretty sure of that. So, I don't know. There's patterns. So that's the point. The AutoML will figure out the patterns. So provided it doesn't even matter. Okay. So, time. Okay. Fucking. God damn it. Okay. Fine. Whatever. Okay. Okay. I think I need to go. I need to go for a walk. All right. Okay. Fuck. Hmm. Okay. System context. Let's play with this API. Let's play with this API. Okay. Okay. NodeMon. All right. System context / system context.py. All right, so 86. Duh. Okay, so let's just do return. Attempted. System context, base. Attempted relative import with no known paired package. Indeed. Indeed you did. Okay, let's see. There we go. Overlay, great. We got a problem with the overlay. Of course, that's why we're here. Let's go rip out the system context stuff. Base config. Oh, wow. What happened there? You know, something went wrong when this file is screwed up. Okay. All right, that's God, I wish Vim would show me the file it's in. clean up a few more things here. Okay, what is this? What the hell is this? Where did this come from? What is this? What is this? What is this? Jesus, what was this? What happened here? Did I just write? I just threw and didn't I did that. I did do that. Just threw a whole bunch of code right in the middle of this for no reason. Okay, great. Okay. Merge. Entry point. This is a new one. Oh wow. Oh, okay. Type entry point has no. This is not a fun one. Is what this one is. Type entry point has no attribute annotations. Where did you get this? Overlays installed. That export. Entry point has no. Okay. Okay. So what are we looking at here? Plugin base. Overlays installed. Plugin base. Overlays installed. Plugin base. Entry point. Okay. So first off, this is just a horrendous name. So let's go fix that. Frame imitate type. Type. I don't like that. Oh, I hate that too, but whatever. Okay. Class. Oh, wait. All right, okay. Entry point has no attribute annotations. Spec entry point. Spec entry point has no attribute annotations. Export spec. 215. Where are we? $2.15. Name types defaults. So it wants to know annotations. It wants, oh, it assumes what, you're a name tuple or something. Oh. It assumes it's a name tuple. Ah, okay. Because it tries to rebuild a name tuple down there. Which also not a fan of. Okay, I don't like that either. Fuck off. Okay. Alright, I'm taking it